In this problem, we're looking at the hydrolysis of an imine under acidic conditions, acid and water. And one thing to take note of, if we're going to do this reaction, since it's an equilibrium process, to drive this reaction to the hydrolysis product, we need an excess of water. Now, we can just think about what the basic products are going to be, and what's going to happen is the two hydrogen are going to go on to the nitrogen to give us, in this case, a methylamine. And then the oxygen is going to get substituted onto this group as a carbonyl. So those are the products, but let's take a look at the mechanism and see exactly what's going on here. Now the conditions for this are acidic. So we have a proton, and we need something to protonate, and what we have here is the lone pair on this nitrogen of the imine. So that lone pair is going to grab the proton and protonate the imine. We still have the methyl, but now we have a hydrogen, and this nitrogen is now positively charged. It doesn't have its lone pair anymore. From here, this is almost like an activated carbonyl, where we have this electrophilic carbon double bonded to the N+. Now what we're going to do is use water as the nucleophile to attack this. The water comes in, attacks there, pushes those electrons up onto the nitrogen, and it wants those electrons because it's positively charged. So here we're going to get now just the methylamine. Except now we have water added and a positive charge on the oxygen. From here we can do a proton transfer to transfer the hydrogen to the nitrogen, which is going to be our leaving group. So we end up with the OH, N-methyl, and two hydrogens on the nitrogen. Now from here, since the nitrogen's a good leaving group, we can use a lone pair on the alcohol to help us displace it. So we'll push that down to form a double bond between the carbon and oxygen and kick off the amine. So here's where we get our amine product. And now we get the double bond to the oxygen, which still has a hydrogen attached. So we need to put a plus on the oxygen. And then our last step, some base in solution can take that proton off of the oxygen, giving us the carbonyl. And then that's the mechanism for the hydrolysis. And then here's our products. We have the ketone and the amine.